All right, so today we have section 413, polynomial functions with multiplicity. So what is multiplicity? It's the number of solutions that a polynomial has. So like every time we give you an equation and we ask you like to solve for it, you could figure out how many solutions you're supposed to solve for by figuring out its multiplicity. Okay, so again, multiplicity is just how many times a zero occurs in a polynomial, how many times a root occurs, or how many times a solution occurs. So those three words, root, solution, and zero, they all mean the same thing. So just kind of want to highlight that for you guys here, okay? If you ever see like find the roots or find the solutions or find the zeros, it means the same thing. Find the answers, okay? So it's just three different words. Different books will use different words. So I just want to kind of put them all out there for you because the state test might use roots, and in college they might use zeros, or maybe they might use solutions, right? So it just depends. But all three of those words mean the same thing. Okay, find the answers. Okay, find the answers. So how can you identify multiplicity? Now, by the way, multiplicity can be even and odd, and right now you'll hopefully understand what I mean by that once we start doing some of the examples by even and odd. But one way you can do it is you're supposed to get the function they give you, factor it, and then you look at the power on the factors. And when you see the examples, you'll see what I mean. But you're going to look at the powers on the factors. If the powers are even, like a 2, 4, 6, 8, 10, then you say it has even multiplicity. If the powers are odd, so a 3, 5, 7, or even a 1, then you say it has odd multiplicity. Okay? If you're looking at a picture, which is easier, I guess, than the other way, if you're looking at a graph of something, then all you have to do is look at the x-axis and see where it crosses the x-axis. Okay? You find the zeros on the x-axis. If at the place where it crosses, the graph just happens to go through the x-axis, then we say that it has an odd multiplicity. If it bounces off, so it kind of like goes down and then hits the x-axis and goes back up, then we say it has even multiplicity. And again, this might not make too much sense right now, but as we start doing the examples, I think it'll make a lot more sense. So again, multiplicity, the point of it is to figure out how many answers a polynomial has. Okay, it could have even or odd multiplicity. If you're factoring, you look at the powers of those factors. That's going to tell you what kind of multiplicity you have. And then if you're graphing, you're just looking to see if it crosses through or if it bounces off. So the stuff in parentheses, that's kind of like your key as to how you're going to tell if it's bouncing off, it's going to be even. If it's going through, it's going to be odd, right, for the second one. For the first one, if the factor has an even power, it's even multiplicity. Odd power, odd multiplicity. Okay? So like I said, it'll make a lot more sense right now when we do the examples. But let me show you one more thing, and then we'll get to the problems. So I'm going to go ahead and pause it so you guys can write this down. All right, so before we get into solving, I want to discuss what are zeros, right? So I kind of mentioned it earlier in the video, but solutions or roots, that's basically what zeros are. It's just another word for solutions, okay? Another word for answers, another word for roots. So you're going to notice zeros. The reason why we call them zeros is because the y value of the point is a zero. So like sometimes you can write the points like 2, 0, negative 3, 0. These are all points that are on the x-axis. So that's why we call them zeros, because the y value is a zero, okay? So, but based on the definition I wrote here, it says these are answers found by solving a function. So every time you guys did a problem where you factored and solved and you got answers, those are called zeros, okay? And why do we call them zero? Because wasn't the equation equal to zero, right? You always had to make it equal to zero. So they're called zeros. Or it's the location where a graph touches the x-axis. And that's important for when we do the graphing part, okay? We're just going to be focusing on where does it cross the x-axis, or where does it touch it. Those are going to be your zeros, okay? But first, let's do the manual ones without pictures. I think we have 3 examples total. So for example number 1, I said find the zeros, find the solution. So what you're supposed to do, you're supposed to have a function. You're supposed to factor it. Notice this is already factored. Both of them are already pre-factored, okay? then you're supposed to set them equal to 0. So this is your next part right here. 2 times x minus 3 times x plus 1 equals 0. And then you're supposed to break it apart. Remember how we used to do that, right? Once you have everything set equal to 0, you say, okay, this is equal to 0, this is equal to 0. We're using the zero product property from Algebra 1. So 2 equals 0, x minus 3 equals 0, x plus 1 equals 0. Okay? Now, 2 equals to 0 is not true, so that's not a solution. I'm just going to put a little mark through that equal sign. That's not possible. Now, what's the power on the x minus 3? That parenthesis. What's on the power? It's a 1. And also on the x plus 1, right? So, remember how in the very beginning I said even and odd multiplicity, right? And when you're factoring, you're going to look at the power. And if the power is odd, then we say this has odd multiplicity. Okay? If the power is even, then we say it has even multiplicity. Okay? So, I can tell that these two answers for x minus 3 and x plus 1, they're going to have an odd multiplicity. Okay? So, let me just rewrite it. X minus 3 equals 0. I'm going to move the 3 over. So, x is equal to 3. Okay? And then this one, I'm going to move it over. I'm going to put x equals to negative 1. I'm sorry, let me rewrite this again. X plus 1 equals 0. So I'll move this over. X is equal to negative 1. Okay? So, my answers, well, x is equal to negative 1 and 3. Now, I can say that negative 1 has odd multiplicity, M-U-L-T, to abbreviate. And I can also say that 3 has odd multiplicity. That means that if I were to graph this function, if I were to actually draw it out, when I get to negative 1 on the x-axis, the line has to go through it. It doesn't bounce off of it. Okay? It has to go through. And when I get to 3 on my graph, it's going to go through it as well because it's odd. Odd multiplicity makes the graph go through the x-axis. Okay? Again, you'll see this once we get to the last example. Okay? But here's my solutions. Okay? So that's my answer. And this was just FYI right here, okay? So not really required, but it's something you guys should think about all the time. Okay? Now, whenever the power is a 1, we don't say that it has multiplicity of 1. Only when it's 2 or higher. Okay? When it's 2 or higher, we mention the type of multiplicity it has. But right now, with the power of 1, and this is what I'm talking about with the powers of 1 right here. Okay? Powers of 1. We're not going to mention those, okay? 2 or more, we'll mention it. So, was this hard to solve? No, it's already factored for me, right? That's the hard part, is factoring. So it's already factored for me, so I can just solve it really quickly, and then I'm done. So look at the next one. I'm going to set this equal to 0, so I'm going to put x minus 4 times x plus 2 times x minus 3 equals to 0. Okay, and then I'm going to split them up. So x minus 4 equals 0, x plus 2 equals 0, x minus 3 equals 0. What are the powers on all of those factors? Just 1, right? If it's not a 1, you'll literally see a 2 or a 3 or a 4. So again, I'm kind of starting easy right now. Okay? They're all powers of 1. Okay? So that means these all have odd multiplicity. When I solve them, they have odd multiplicity because it's a power of 1. Now let me go ahead and solve. X minus 4 is 0, so I'll move the 4 over. X equals 4. I'll move the 2, I'm sorry, let me rewrite this. X plus 2 equals 0, so I'll move the 2 over. X is negative 2. Okay? And then x minus 3 equals to 0. I'll move the negative 3 over. X is equal to 3. Again, easy to solve, right? Not difficult. I'm not having to factor anything. So let me write my answers down. Negative 2, 3, and 4. Here's my solution. Okay? So they said find the zeros. In other words, find the answers. There you go. I did. Now, if they were to ask me, are these even or odd multiplicity answers? Well, they all had a power of 1, right? A 1, a 1, a 1 to begin with. So that's odd. It's an odd power. So I'm just going to write negative 2, 3, and 4 have odd multiplicity. Again, why is that important? Well, if I'm looking at a graph when x is negative 2, when x is 3, and x is 4 on the x-axis, the graph's passing through it. It's going right through, maybe from the bottom and it's crossing the line, or maybe from the top it crosses the line down, but it's going to cross through it. If it has even multiplicity, it's going to bounce off, and I'm going to show you guys that, but in a bit. Okay, example 3. Are we okay with example 1, just solving? Again, no factoring, so this makes it easier. Okay, just set it equal to 0, solve each piece. All right, here's example 2. Find the zeros, but now I want to know their multiplicity. Okay, remember, if the power is a 1, we don't say it has multiplicity 1, but if it's a power of 2 or more, we say it has multiplicity of 2, multiplicity of 3, multiplicity of 5, etc. But again, notice these are already pre-factored for me, so I don't have to do anything in terms of factoring. I just got to solve. So they want me to find the zeros, the solutions, the roots, the answers, okay, and the multiplicity. So here we go. I think I have 2 of them, right? Yeah, I have 2 of them. So for the first one, I'm going to get my equation set up by making it equal to 0. Again, this is why we call them our zeros, because they're equal to 0. I set them equal to 0. Now I'm going to spread them up. So x squared is 0. X minus 1 cubed is 0. X plus 2 is 0. Now, when you're trying to solve for multiplicity and you're trying to solve for answers like this, all you have to do is pay attention to the thing that has the power. So you see how it says x squared equals 0? The thing that has the power is x. So I'm just going to write x equals 0. Okay? And let me go to the other one. X minus 1 to the third equals 0. So I'm just going to write x minus 1 equals 0. The power of 3 is nice. It's going to tell me the multiplicity of it. But I'm just trying to solve the inside part. Okay? So I'll move this over. So I get x equals 1. And then the other one has a power of 1, right? I'll write it down right here. Power of 1. So I'm just going to write x plus 2 equals 0. Move this over. X is negative 2. So this is going to sound really weird. How many answers did I find? I found 3. The 0, don't forget x equals 0. I found 3. But there's actually 6 answers. I can see 6 total answers. Okay? Why are there 6 answers? Well, how many times does 0 happen? What's the multiplicity on the answer for 0? So look above it. What was the power on x? 2. That means that 0 counts for 2 solutions. Now, I also solved for x equal to 1. Look up. What was the power on the statement for x equal to 1? 3. That means that the value of 1 has an answer of 3 occurrences. So I have 2 zeros, I have 3 1s, and how many times does negative 2 happen? just once. That's 6 solutions. 6 total answers. I know I only found 3, but it's because some of them have multiplicity. That means they occur more than once. Okay? So, here's how you write it. I'll start in numerical order. -2. Well, that has multiplicity of 1. Remember, we don't mention that. So I'm just going to write -2. If it's just a multiplicity of 1, don't worry about it. Just write -2. All right, then 0 would be next. How many times did that one happen? Go back and look real quick. X equals 0. It happens twice, right? So x equals 0, let me highlight it. This one occurs twice. Okay? So I'm going to write multiplicity 2. So mult of 2, meaning it occurs twice. 0 multiplicity 2. It occurs twice. And then 1, how many times did that one occur? 3 times. Multiplicity 3. And I'll highlight it for you just to kind of have a little bit of a easier time identifying it. Okay? And then the reason why -2 doesn't get mentioned is because it only occurs once. So I'm not trying to tell it's more than 1 time. So how many answers do I have? Well, I got 3 1s. So that's 3. I got 2 zeros. And I got a -2. That's 6. Okay, so 6 total answers. Now, if we were going to ask you if it's even or odd, I'm not going to write it down. Let me just kind of really quick mark this off as done. But was the answer 0 an even or an odd multiplicity? Even, because the power was 2 on it, right? Was the answer of 1 an even or an odd multiplicity? Odd, because the power was 3 on it. Okay? And then -2, even or odd? It's going to be an odd, a power of 1. Now, I'm not saying is the number -2 even or odd, because that answer would be even. But I'm asking you, look at the power where it came from. Is it even or is it odd? Okay? So, all right, let's do this one right here. And then we're going to do a picture and then we're done. Okay? So f of x is equal to x times x minus 2 squared times x plus 1 to the 4th. Just out of curiosity, can anybody tell me the total number of answers that I'm supposed to get? 7. Yeah, good, 7. Because the power of 4, a power of 2, and then a power of 1, which we don't see. So 4 plus 2 plus 1, that's 7 total answers. But it's not going to look like we find 7 answers. It's going to look like we're only going to find 3. But just that some of them count for more than 1. Okay? So, all right, let's go ahead and do this. So x minus 2 squared, x plus 1 to the 4th. We're setting it equal to zeros because they said find the zeros, so I got to set it equal to 0. First one, x equals 0. Well, there's not much I can do with that. That one's done. Okay? Then x minus 2 squared equals 0, and x plus 1 to the 4th is equal to 0. Now, when I start solving, the left side is already done. There's not much for me to do there. That's it. X equals 0 is x equals 0. Okay? Now, x minus 2 squared equals 0. Well, I'm going to rewrite x minus 2 equals 0. Remember, you're just focusing on the inside of the parenthesis. Move the -2 over, so you get x equals 2. Okay? And then, let's solve for the last one. X plus 1 equals 0. We're going to move that positive 1 over, so x is -1. Again, I see 3 answers that I solved for, -1, 2, and 0, but they have multiplicity, right? So, we'll start off with -1 because we're going in order. -1 has multiplicity of what? 4, right? Yeah, so 4. That's the original power, and again, I'll highlight it here. So -1 multiplicity of 4. So we would say that -1 has even multiplicity, right? Because it's a multiplicity of 4. All right. Next one would be 0. Does that one have multiplicity? No, because the power is a 1, and you don't say multiplicity of 1. Like you don't multiply it once, right? So we're going to leave it alone. And then 2 has multiplicity of 2, okay? So we would say that 2 has even multiplicity as well. So when it comes to solving and using multiplicity when you're doing like formulas like this is as far as it goes, okay? So it doesn't go any further than this. They're just going to say, like, tell me the answer and how many multiplicities they have. If it only has a power of 1, you don't write anything. But 2 or more, you write it, okay? So again, we're looking at those powers, right? So right here, 2 multiplicity of 4. Whereas 0, well, it was x to the first. That's where it came from. It's just the power of 1. So are we okay with, oops, hold on, I messed up on this one. Should have been right here. Sorry. Are we okay with this so far? So this next one, I'm going to pause it to give you guys time to write this down. And then we're going to finish off with the picture. All right, so for example number 3, I ask you 2 different questions. How many zeros does this graph have? And which zeros have even multiplicity? Which ones have odd multiplicity? So for part A, when I ask you how many zeros does it have, I'm going to list them right now. So part A, the number of zeros, there's 4 of them. There's one at -2, one at -1, one at 2, and one at 3. Because that's where the graph touches the x-axis or goes through the x-axis. Either it bounces off or touches it, right? Or goes through. So there's 4 of them that occur. Okay, so -2, it's right here, right here, right here, and right there. Okay, now for part B, it says which zeros have even multiplicity and which ones have odd. So we talked about it earlier. Just go ahead and start putting your stuff together. Look for the ones that bounce off. Okay, so I'll list them right here.
I have a 10 old homework assignments to.
Oh, you can just put them right there. Yeah.
Awesome, thank you.
Bye.
Did you do it? When is homework due today?
Today or tomorrow.
What?
How you doing?
How are you?
I'm good.